So problem 6 and 7. Problem 6 first. 9x plus 27 equals negative 72. It's a two-step problem. X is being multiplied by 9, and then 27 is being added to that product. So what do we undo first? Well, the last thing that happened was a plus 27. That is the first thing that we undo. So how do we undo it? Well, we undo it with a minus 27. So we take everything that was written there, minus 27 equals everything that was written there, minus 27. Okay? These two undo each other, leaving just 9x. And you have to make sure you do this math correctly. You're down 72, you go down another 27 from that. Those are negatives and negatives, so it becomes more negatives, negative 99. 9x equals negative 99. Now you say, what's happening to x? It's being multiplied by 9, so we undo that with a divided by 9. The inverse operation using the exact same number. The inverse of times 9 divided by 9. And if we do it to one side, we do it to the other. So negative 99 divided by 9. 9 over 9 is 1x, just x. And negative divided by positive is negative. And 9 goes into 99 11 times. So x equals negative 11. To do the proof, we write the original equation unmodified. On the next line, we write the exact same thing. Don't do anything to start to simplify it except replace x by substitution with what it is equal to, negative 11. And anytime we substitute, we put parentheses and substitute in. Okay? Now we're following order of operations. I said this in other problems. We don't need to know what's on that side of equals right now because it's gone from being an algebraic expression, algebraic expressions contain a variable, to a numerical expression where they're all numbers. And once we've done substitution, this is a numerical expression, and that numerical expression can get simplified without regard to what's on the other side. So we can just ignore what's over there first for a second because it's already a negative 72. There's nothing to do to simplify it, so that just keeps moving down, moving down, moving down. What we're really worried about is simplifying this. And if we look at that negative 72 over there, it might influence what we're writing. We don't want it to. We just want to take the numbers and do the math and say, what does it result in? Because if there was an error here somewhere, this is where you're going to find out when you just do the correct math. So the first thing we do is multiply. 9 times negative 11 is negative 99 plus 27. Now we've got to do this. How do we think about this if we're trying to do the math on this? Well, you've got 99 negatives, and we are adding 27. Since we're adding 27, these 27 positives cancel out 99 of these negatives. So let's take 99 negatives and take away 27 of them because 27 of them got canceled out. And what do you get? Well, 9 minus 7 is 2. 9 minus 2 is 7. So that means we've got 72 left. But what were they? They were negatives. Okay, you can see the bigger number was negative, meaning we should have negatives left over after using all of these positives to cancel some of these out. So even though we reversed the numbers and said 99 minus 27, okay, we were just finding out how many negatives remained. And 72 negatives remained, so therefore negative 72. Okay, I'm just trying to help you understand how to think about and deal with integers. Okay, so now we say negative 72 equals what? And this is negative 72, so check. Okay, again, I'm seeing lots of problems where kids are trying to force the numbers to work, and they don't actually result in the number they should. And what that means is there's an error somewhere, but they're just forcing it into place and writing the number that would make it correct, even though it's not correct. We can't do that. I won't give you any points if you do that, because you're not legitimately doing the proof to find out whether it's right or not, okay? Now, number 7. Negative 34 equals 6m minus 4. What's happening to m? It's being multiplied by 6, and 4 is being subtracted from it. You probably know at this point that we will undo this negative 4 first with a plus 4, okay? So we write everything that was there, negative 34, and our change of plus 4. We write everything that was there, 6m minus 4, and then our change of plus 4. Now when we resolve it, this negative 34 has 4 being added to it. These 4 cancel out 4 of these negatives, leaving only 30 negatives remaining. 30 negatives, or negative 30. And here these two undo each other to leave just 6m. This is the line that is just the simplification of the line before it. We need to see what this simplifies into all by itself. Leave it there. New line, undo what's happening to m. M is being multiplied by 6, so we undo that with a divided by 6. Okay, negative 30 divided by 6 equals 6m divided by 6. Do it to one side, do it to the other. And now negative 30 divided by 6, negative divided by positive is negative, 30 divided by 6 is 5, so negative 5. And here we've got 6 over 6, or 1m, or just m. Negative 5 equals m. Put a box around it. Now for your proof, write the word proof, and then write the original equation unchanged. On the next line, the exact same equation, exactly the same way, except the one thing that you do differently is wherever there was a variable, you put parentheses instead of the variable, and you replace the variable with the value you believe it to be negative 5 inside the parentheses. Okay, so now we've got a numerical expression over here, and we don't need to think about what's over here. This is negative 34, but we can ignore it for the time being. I'll do the same thing again and just cover it up for a minute because we don't need to worry about that. What we're trying to do is just simplify this. Following order of operations. First thing we do is multiply. 6 times negative 5 is negative 30. This comes down because we haven't dealt with that yet, so we just copy it down the same way. This just simplified into that. And so we say now negative 30, we're down 30, we go down another 4, now we're down 34, negative 34. And at this point, we look at the other side to compare it and see if it equals what we wanted it to, and yes, indeed it does. Negative 34 equals negative 34. Check.